Today we're going to talk about neutralization reactions. These are reactions that you're already familiar with by a different name. They're double replacement reactions. When an Arrhenius acid and an Arrhenius base react in the proper ratios, they neutralize each other. So the acids and the bases get used up and then make a water and a salt in the process. For example, we have here HCl and NaOH. HCl is an Arrhenius acid because it starts with H, and NaOH is an Arrhenius base because it ends in OH. We first look at these as if they're ionic compounds by separating them into their separate cations and anions like this. So we have H plus and Cl minus, we have Na plus and OH minus. Next, we perform a double replacement reaction, so we just switch the H and the Na. So these reactants become these products. We now have Na with the Cl and H with the OH. We need to crisscross these, but in this example, everything has either a +1 or a -1 charge, so we don't really end up with any subscripts. We end up with NaCl and HOH. Another step would be to balance this equation, but there's no need for that either since it's already balanced. So what's happened? We've had an acid and a base yield a salt and water. Neutralization always results in a salt and water being formed. There are 4 steps, which are pretty easy to remember. Those are the 4 that we just went through. The first is to consider the acid and base as ions. Next, swap the cations in a double replacement reaction. The third is crisscross the new compounds. You want to be sure not to bring over any subscripts that don't belong to a polyatomic ion from the reactant side to the product side. You're going to take care of that with a crisscross. The last thing is to balance the equation. Let's look at this example. We have chromic acid and nickel 3 hydroxide. I know that the chromic acid, the CrO4 part of this, has a -2 charge because there are 2 hydrogens here, which are +1 each. So the chromate ion is a -2. I know that this is nickel 3 because there are 3 OHs, which are each -1. So that would make a -3 charge total for the anions, which means the nickel has to be a +3. I'm going to need those charges when I crisscross the salt in just a minute. But first, I'm just going to into their ions. Now, notice that I didn't bother to keep the subscripts because they're going to change in the products. I just want to see what the ions are so that I can do my double replacement. So I'm going to swap the hydrogen ion here with the nickel 3 ion. And that means that I end up with the nickel 3 being with the chromate and the hydrogen being with the hydroxide. The next thing I need to do is to crisscross these. So I need to take my 2 and move it down to here. Of course, I don't include the sign. I know that's a -2, but we just put the 2 down there. And next we take the 3 and we put it down there. Now, because I have a polyatomic ion and there's more than one of them, I need to also put it in parentheses. So I put parentheses around my chromate ion. And basically I now have this. I have Ni2 and then in parentheses CrO4 with a 3 outside of the parentheses. Now I also need to crisscross my, but it's pretty easy because H is +1 and OH is -1. Now I've written HOH for water instead of the normal H2O. The reason I did that is to emphasize that one of the H's comes from the acid up here in the chromic acid, and one of the OH's comes from the hydroxide of our metal hydroxide or our base. So that allows me to put my H and my OH together, which makes balancing much easier. The last thing I need to do is balance this equation. So I have H2CrO4 plus the nickel 3 hydroxide yields the nickel 3 chromate and water. A trick to balancing is to do the water first. I know that one H and one OH will yield one HOH, or water. So I just need to make sure I have the same number of H's in my acid as I have hydroxides in my base. Since I can't change the subscripts because that would change the formulas, I can only change the coefficients in front of each of my compounds. Now, if I had only one hydrogen or only one hydroxide, then it would be easier because all I would have to do would be put a coefficient in front of the one that only had one to make it be equal to the one that didn't. But here I've got two hydrogens and three hydroxides. So since I can't make a 2 into an odd number, and I can make a 3 into an even number, I'm going to make this 3 into an even number by multiplying this compound by 2. I put in a coefficient. So now I have 2 times 3 hydroxides, so I have a total of 6 hydroxides. I need to have 6 hydrogens. I can't change the subscript, but I can multiply this by 3, and now I have 6 hydrogens. So I have 6 hydrogens, and I have 6 hydroxides. So how many waters can I make? Remember, it takes 1 hydrogen and 1 hydroxide to make a water. So since I have 6 of each, I can make 6 waters. Don't fall into the trap of dividing your hydrogens by 2 to make water. We did that with combustion reactions because there are 2 hydrogens in water. But remember, the hydrogens in the front part of HOH are coming from the acid, and there's another hydrogen in the back part, the hydroxide, the OH, that's coming from the base. So really, I just need 1 hydrogen and 1 hydroxide to make 1 water. The last thing I'll do is just check my salt here. I see that I have 2 nickels, and I have 2 nickels up here. If I check either the anion or the cation and everything is good, then I don't have to check the other because it has to be right. I have 2 here and 2 here, so it balances as it is. I can put a 1 in this blank to indicate that I've looked at it and make sure, but as it stands, this is the final balanced equation. Now take a look at this one. Follow all 4 steps. Separate your cations from your anions. Make sure that you figure out your charges for your anion here, your PO4, which you can find by counting the hydrogens, and find the charge of your cation, your magnesium, which you can find by counting the hydroxides. You'll need them on your salt on the other side. Swap your 2 cations in your double replacement reaction. That will give you your 2 products, your salt and your water. Then crisscross your compounds. Of course, you only need to crisscross the salt. The water is just HOH. And finally, balance your reaction. Pause the video here until you're done, and then check your work. Okay, if you've done the work, check here and see if you got the same answer that I did. You should have had 2 phosphoric acids plus 3 magnesium hydroxides yields 6 waters, and the salt is magnesium phosphate, which is Mg3, and then in parentheses PO4 2. We got this when we crisscrossed because magnesium has a +2 charge, so the 2 goes down here, and the phosphate has a -3 charge, which comes down here. The waters, we ended up with 6 of those, because to balance the H's and the OH's, since I had an odd number of hydrogens here, I made it even by multiplying by 2, gave me 6 hydrogens. I needed to have 6 hydroxides, and I started with 2, so I multiplied by 3. That gave me 6 hydrogens, 6 hydroxides, so I could make 6 waters, and the salt took care of itself.